like Earth is moving and it's also revolving around the sun at the same time. So at this part of time, at this part of the season, you'll only be able to see Gemini, Cancer, Leo in the sky from the zodiac family. There'll be many other constellations, but from the zodiac family, you'll only be able to see Gemini, Cancer, Leo, and from March to June, you can only see these, and so on. Any questions?
Isn't Leo supposed to be visible in August?
Yeah, I think this is probably from a different area.
Probably.
Yeah, it'll differ depending on where the person is viewing it from.
Yeah, and I think time of the year also
Yeah,
helps.
yeah. But these constellations will always be there. Like it'll be there in a certain line following. It'll be there in the same path as the sun, basically. So one
Um,
constellation will be on top of each other. They won't be changing directions like one on north and one on south. It'll be there in a straight line.
um, Devin,
Yeah.
these zodiac family constellations are, is there like really any science behind it, or it is just that we have to like take 12 zodiac signs, so we just made some design in the sky and we found ki acha this is lion and this is
Yeah, so
scorpio.
probably like back then, astronomers they would have just chosen a theme, and based on that theme, they would have chosen, oh, this looks like Leo, or this looks like Gemini, like that. They just named it randomly because even if you actually see few constellations, it doesn't really look like what they're named after, but maybe it looked like to the person who named it.
Okay.
But it's just a theme.
Yeah.
And back
Thank
then,
you.
people used to think like the outer space is the heavens and so on. So yeah.
Yeah, got it. Thank you.
Okay. So I'll come to locating features. So when you're stargazing, like you're outside on a terrace or you're in a garden where there's a lot of space. So the first thing you'll want to know is the cardinal directions like north, south, east, west. And then there's sub cardinal directions like northeast, southwest, like that. And there's another one also, north, south, south, or east, east, south, like that. There's basically different versions, making it easier for you to identify where each constellation will be. So the meridian is a imaginary circle or a line that splits the sky into two halves from south to north. And right in the center of the meridian is the point we call zenith. The point where you look straight up, that'll be the zenith for you. Now, the ecliptic will be the path that the sun and most of the planets will be in that similar line following. So if the sun is following that line, the planets will probably be pretty close to that line since all of them are revolving around sun. And the celestial pole is the part where the axis is spinning. So there's one star where it's right at above the access point. So it's just there, like it won't move. It'll be there constantly. Like for example, if you were to stand in North Pole while it's the while it's the night time, which would take few it's I'm not sure how many nights, but like there's a there's a season where it's in the winters it's always nights. Like it's never daytime in the North Pole. So if you look up at the zenith will be this star called Polaris, the North Star, and it that's the celestial pole, and all the stars will be rotating around. So if you looked up, they wouldn't rise or set; they just be rotating in the sky.
Is rotate
You muted yourself.
You rotate the stars, yeah? The link?
Yeah, the stars appear to be rotating from Earth.
Oh.
No, so this
Ah,
North Star that we see from the sky, in the sky, it's supposed to be like you read, right? That like people who are on ships and all, they use the
Yeah,
North Star to guide them.
yeah.
So, can you just tell us a little bit more about that North Star?
Um, I haven't actually done much research on the North Star
Okay.
specifically, but the North Star, since it's the point, like the celestial pole is there, so it's like one point. It doesn't move, so people use that as, yeah, the
Yeah, as a
point.
marker.
Yeah, as a mark.
How do you find the North Star?
So, so the North Star is, by the name, it means that it's towards the north. Uh, I wish I could like show you exactly where it is, but if you were in the North Pole, then if you look straight up at the zenith would be the North Star, but uh, the North Star from uh, the North Star from here, from Bangalore, would probably be at the horizon, slightly like 25 degrees above the horizon. It would probably be around that area. I'm not exactly sure. I wish I could show you, but I don't know how to
have
find
picture,
where it
yeah?
is. The North Star just look like any other star. It's not different, but it's the star that helps you. Like it's the star that's always there. It doesn't move.
You can see, yeah.
Is the North Pole a bit brighter?
Sorry, I can hear you.
Is the North Pole star a bit lighter?
No,
Brighter.
yeah, it's bright. Okay, the next feature is the clock. So like say you want to find an object that's towards the south, then you could say, suppose you know an object, like for example, the North Star, and let's say Saturn is like towards slightly close, and you want to tell someone where it is, you could say like uh, Saturn is 12 o'clock from the North Pole. I mean the North Star. Get it? So you're basically looking at a clock, and above the North Pole, I mean the North Star, would be 12 o'clock, and below the North Star would be 6, 9, 3. Yeah. So do you guys get it? If you didn't, please ask. Okay, moving on. So the so we can measure distances, but obviously not using a measuring tape and scale. Like that would be really funny though. You could try it, but uh, yeah. So how we measure distances is simply by using your own hands. So if we were to, like, we talked about the meridian, right? So if we so like the meridian splits the sky into two halves, from the south to north and north to south. And if you put a protractor one of the sides, the sky would approximately be, from horizon to horizon, it would approximately be 180 degrees. So this is how we measure. So uh, and if it's 180, approximately 180 degrees, then uh, from horizon to zenith, it would be approximately 90 degrees. So if you hold out your hand and you keep it like this is about 25 degrees of the sky. So you can measure the sky like this. And this would be 15. This would be 10. This would be 5. And this would be 1. So you can keep creating different variations like 15 plus 25, and like you can keep experimenting. But yeah, that's one way we stargazers measure the sky. Any questions? No?
From which point do you start measuring, like, for
From
example?
the so like I said, right, anywhere from the sky actually, like we're just measuring the skies using degrees.
So do I start with any direction, or do I start with
Like say there's one star. 1 minute. There's one star, and there's one star here, and there's one star here. Then you can measure and see how many degrees it is approximately. It won't be the exact, but that's the approximate. And as funny as it sounds, like the moon is actually just half a degree. So if you can literally cover the entire moon with your pinky.
is it so?
Yeah, you can try it. It should work.
Oh, that's it.
Okay.
Devi, you told something of 12 or 6, you told something, yeah?
Yeah, I was saying the clock analogy. So you imagine as the one star that you're looking at is a clock, and you give directions based on that. So if that's the clock, then like 12 o'clock from that, the star would be above, like above the star, and 6 o'clock would be below, and 9 o'clock would be towards the left, and so on.
David, first I saw 3 stars in straightly, one
Mhm.
by one. Straightly, I can see.
Yeah,
It is not star, huh? I didn't see.
no,
It
that's
is
not a
not.
north star.
Okay.
Okay, so we'll come to stars and planets. So how do you differentiate these objects that appear alike? Like if you see in the night sky, all of them look the same. Like how can you tell this is Saturn? Just like forget the names are there, but how can you actually tell this is Saturn and this is not Saturn? How can you tell this is Mars and this is not Mars? So how can you tell that?
We get
So
confused.
yeah. So people get confused. So how we know is
Tell. You can tell because of the yellow letters stuck to them.
In the picture, but
yeah,
not
in
in
the
the
picture.
actual sky.
Yeah, so that's why I said ignore the words.
Yeah,
Okay.
actually, also when we used to look to the stars, one planet that I could see that was a star was Mars because it was a bit more like orangish. So, like, you could kind of tell that it was Mars.
Mm-hmm. Yeah, that's also there. Okay, so I'll come how you can differentiate. So stars are like fiery balls of gas. They so it's like it's really bright and they're emitting their own light, right? So they'd constantly be twinkling. Whereas planets, they don't have their own source of light. Their light is being reflected off sun. So the sun's light is being reflected off them, and that's how we're able to see. But the planets, they don't twinkle. So if we see the night sky and if we think that that's a certain planet, to make how we make sure is to see whether it's twinkling or not. But there are certain cases like Venus and Mercury, because Venus and Mercury usually only you can only see them usually at the horizon because they're constantly with the sun, right? They're very close to the sun. So at the horizon, the atmosphere has a lot of elements, and like the light that's being reflected off Venus and Mercury enter the atmosphere, and the atmosphere is like disturbance. There's a lot of pollution and elements, and that's causing the color change you see. Like if you sometimes you see stars changing colors from red to blue and so on, and like you keep wondering what is that. So that's basically
Why it's changing colors, sir?
yeah, so the atmosphere is causing that disturbance. The atmosphere has a lot of elements, pollution, and it's causing that disturbance. So at the horizon, the atmosphere from our perspective is the most. The atmosphere straight above would be even more less considering from the horizon. So that's why there's more red blue activity from the horizon than there is when it's above the sky at the zenith area. Any questions?
Which date will come, this, David? This
Sorry.
Right.
Say it.
I'm asking
You wanted to
which
ask something?
dates. Yeah, I'm asking which dates. This planet's dates is this.
Yeah, so planets keep revolving around sun. They're keeping moving and they're even closer. So they keep constantly changing each day. So like if Mars was here today, then Mars would be here tomorrow and so on. It keep moving around.
Okay. I'm asking dates is the dates. Today's Mars is coming, tomorrow Jupiter is coming. That I'm asking.
Yeah, there are dates. But
I'm
yeah, it
asking
keeps
that
changing.
one.
There's no certain date as to when Jupiter and Saturn will come. It'll keep changing.
Saturn comes closer by Jupiter and Saturn, middle, closer and closer, both of them. Yeah.
That's called a conjunction, but that's another thing. Okay, shall I move on? Okay. Okay, now I'll come to the types of telescopes. There are 3 telescopes. By me explaining these telescopes doesn't mean you have to get one of these. I'm just explaining how it works. So we have 3 types of main telescopes: refractor, reflector, and catadioptric. So refractor telescopes, as the name suggests, the light that's coming from the object that we're seeing bends through this glass, like the glass, and it bends right through the eyepiece, so we're able to see that. But the problem with refractor telescopes is sometimes it causes color fringing, and like if you're getting a refractor telescope, then you'd have to get a really good one. So why am I trying to market telescopes anyway? And then there are reflector telescopes. The one we have at campus is a reflector telescope. So the light enters through the telescope. There's a mirror at the back, and it reflects through from the mirror. And there's another mirror that's there in the center. But first it hits the mirror behind, and then that mirror hits the light hits the mirror inside that's facing inside, and it comes through the eyepiece. So with reflector telescopes, usually we see the objects uh, upside down. So that's why we have a finder scope with reflector telescopes that help us find the object first, and then we're able to see the object. Because if we try to find an object through the reflector telescope from the eyepiece, it would be really difficult since it's upside down. It's yeah. And then there's catadioptric, which is basically a mix of refraction and reflection. It has both. So it enters, and then there's mirrors. This is basically it refracts from this, and then there's mirrors, and then more mirrors, and it's basically a mix of both. But this is more for like professionals and more variety of objects. The basic one would be a reflector telescope. Any questions?
I guess we need to understand a bit more about how light travels to understand these telescopes.
Yeah, yeah. Um, okay. Now I'll come to the final thing. Is to explain how to basically do simple stargazing. So, while you're deciding to stargaze, you might want to see if you like. There are apps like on laptops. There's this amazing software called Stellarium. It's free and you can find it at the store. You can get it. It's really simple to use once you learn how to use it. And
More app also there.
yeah, on phones also there are apps you can use. And
They,
Oh, what's the app name, Kevin?
Like that sky map with Papa says. So if you press manual, then
One sec, that
there are two people speaking at the same time.
if you move your hand, then if you press manual and move your hand, then you can see it. But if you press auto and just turn the phone, you can see different things.
one sky map app.
Okay, I haven't really used Sky Maps much, so I wouldn't know.
David,
I
one
use
more app
Stellarium.
also there, David.
Yeah. Okay.
Night.
Yeah, we have the app planets.
Yeah. So it's cool to just have these apps and exploring them and getting to know. You can learn a lot of about basic stargazing through using these apps also. Then you wanna,
David,
yeah.
what's the app name? Can you type it in the chat?
Okay, the app name or the software?
The software.
Yeah, I can type it.
Yeah.
Stellarium.
Oh, okay.
What is
Thanks.
the app name?
Stellarium.
Oh, you can type.
Yes, it's typed.
Okay. So uh, you can try finding the timings of when planets come, and so before you start stargazing, you want to make sure you're not the lights are switched off and you're not using your phone. You just give yourself maybe a 10 minutes of uh, without light hitting your eyes, artificial light, and then
You can easily experience it when you're in the from the light. If you go to the darkness and from darkness to light,
yeah,
so how your eyes will react and what all you can see once you're used to this dark light, and how many things you can see and all these things. It will be amazing to just experiment with light and dark also.
yeah.
I was shocked that when I experienced this for the first time in the night in one of the stargazing.
With our naked, once with our naked eye, we saw the International Space Station.
Yeah, you can see it like it's like a star that's moving.
In Stellarium app, you can even see exactly when International Space Station will be crossing your
Yeah.
coordinates and all that. Unfortunately, it does not cross where we live. The nearest
Mm.
But so what? Sorry, just going back to what you were saying earlier, you and Leela, that before we start stargazing, we should basically just sit in a little bit of a dark space for some time to
Yeah,
rest our
without
eyes.
artificial light, like you switch off lights, don't use your phone. If you have to use lights, I'd suggest you use the red lights.
Okay, warm lights.
It is free, huh, David?
What?
It is free. It told the word, yeah.
Hiren, you're not clear.
Wait. It is free, huh?
Free.
Yeah, it was.
Which is free, Hiren? You're asking about the app?
Yeah, app.
Yeah, Stellarium is free. There's also a
Okay.
paid version, but we only need to use the non-paid one. It's not necessary to get the paid one. Okay, then you can just actually you don't have to really know the names of the stars. You can just use your own imagination. But then, like, you can use these apps to find timings of these specific objects you want to see. You can little research about them, and then stellar or any of these apps, you can see what time they come, and then like prepare yourself 10 minutes before without darkness. And uh, if you like if you want to see it little more closer and you don't have a telescope, uh, you can use binocs. If you don't have binocs, it's actually very satisfying just to see it naked eye also. uh, uh, yeah, then there's also shooting stars you can see. But all these, you actually want to be in a clear place, like not in cities, because in cities you won't be able to stargaze. There'd be light pollution and dust and all that. So stargazing in cities is not ideal. You want to stargaze in places like campus. Campus also has little light pollution, but it's bearable. But you actually want to go a little far away, where there's actually far away from cities. And yeah, but even I haven't seen the sky like how this image is. And yeah, any questions?
We saw the night sky like this. We live in Dubai, so we went to like a really dark desert, and then we
Wow.
saw, yeah.
Yeah, that must have been great.
Yeah, that must be nice, Anushka.
Yeah, it was meteor shower.
Oh, you saw meteor showers, yeah. So this thing you're actually seeing here is actually the Milky Way galaxy, the galaxy we live in.
Yeah, that's actually what we saw there.
Yeah. So this is the galaxy we're a part of.
I just remember Ravi sharing about the colors, huh?
No, but this might actually be real colors. You might actually see it like this. I'm not sure. Yeah, like what Ravi
No,
uncle said yesterday.
that's not how we saw it.
Oh, okay. So yeah, yesterday I wasn't able to cover a few facts. Speaking of galaxies, so I'll cover those.
1 minute. Hiren, you were asking some doubt on black holes. Did you connect with?
Yeah, he sent me a few images of supermassive black holes.
Okay.
Yeah, I sent to him. He didn't respond also.
You didn't really ask what
Yeah,
you. I didn't get your question.
I sent to you.
Yeah, you sent me a picture of a supermassive
The
black hole, but I
yeah, I
didn't get
sent
the
you.
context. What did you want to know?
You just wanted to share the picture, or you had some question when you were sending, Hiren?
Okay, then will get with me
Yes,
on that
sure,
in
he'll
Discord.
connect with you.
Yeah. Okay, so galaxies, we weren't able to cover this yesterday. So galaxies are basically a collection of all the objects we saw before, like black holes, exoplanets, brown dwarfs, star clusters, nebula, stars, and like asteroids, comets, planets, and planetary systems. All that is part of a galaxy. And the galaxy, if we're getting in numbers, is 70% hydrogen and 25. So yeah, we don't need to get into numbers, but it's basically filled with a lot of hydrogen and helium, the basic components to create a star. And so there are three types of galaxies, and galaxies come in many sizes. So one is the spiral galaxy. The Milky Way galaxy is a spiral galaxy. Uh, and then there's an elliptical galaxy, a galaxy that is in a shape of an egg. Yeah, to get a rough idea, it's in the shape of an egg. And then there are irregular galaxies, the galaxies that don't have a specific shape. It's in a weird shape, odd shape, doesn't have a specific shape. Um, any questions? Okay, so most of
David,
the yeah,
can we see different galaxies?
from from Earth.
Ah,
No, we can only see. I mean, we can see through telescope. Yeah, we can.
oh,
But naked eye, we can only see the Milky Way galaxy, like I showed in that picture.
yeah, because it's our own galaxy.
Yeah.
You have a picture of an elliptical galaxy? We can always Google it if you don't.
Yeah, I can Google it now if you want.
What is can you, you had a slide on light years I saw. Can
Oh yeah, yeah, I can get to that 1 minute. So these are basically electrical galaxies. These.
One more galaxy is there, yeah?
It's in the shape of. It has an elliptical shape. Okay, so galaxies. Most galaxies in the universe have a supermassive black hole in the center of them. That's like their main point of gravity that's holding the galaxy together.
Devin, in the spiral galaxy, so what? So why is it spiral? We know how the spiral shape will be like. So what are those lines around all the purple or the pink
Yeah, so
light?
those are arms, like how you'd get in a cup of coffee when you stir it. It's basically just spiral arms. And there, I think it's just based on theories, but they like because of the supermassive black hole, it's rotating around really strong gravity, and the gravity is just causing this spiral. There's just theories that I don't think there's a definite explanation to why it's in a spiral shape.
Okay.
Hey, Davin, I was asking, sorry, we got disconnected. I was asking, do you have, can you take us through the light years on
Yeah,
a,
yeah, yeah, yeah. Yeah. So 1 light year is basically how long light takes to travel in 1 year. I mean, how far light can travel in 1 year. My bad. It's not based on time. It's based on the distance. So in 1 light year equals to 9 trillion kilometers approximately, and 1 light second would be 300,000 kilometers.
3 lakh kilometers? So
Yeah. So
if
you can see the
one light
different.
minute is the time taken for light to reach from the sun to the earth, but a light year is the amount of distance light can travel in 1 year, and light is the fastest thing that we know in the universe.
Is there anything faster than light? I have another question.
Yeah.
Is the universe expanding, or has it stopped, like, expanding, or is it like becoming smaller?
Yeah. So we're probably at a stage where the universe is just born, but our existence is actually very minuscule. So yeah, the universe is actually just expanding. It's continuously expanding and accelerating, and this is just the observable universe. Like there's more, but we don't know where it is yet.
Okay,
Like
thank
how much
you.
of it is there, we don't have an exact number. We can throw numbers, but so this much is just 1 billion light year.
Wow.
Yeah, the universe is really big.
Thank you.
No problem. So I'll show a video. Hope you'll be fascinated by it. Is it clear? Ah,
You're not sharing your sound.
okay. The sound isn't actually important, but yeah, I can share it. Is it audible and can you see the video?
Yes.
This universe.
That's just the observable universe.
Oh,
We are just a speck, not even a speck.
Yeah.
Yeah, our sun no, supposed to be the biggest thing in the world is actually the tiniest thing.
Tinier than so many things.
And Earth just disappeared. Yeah, and like our sun is even smaller than the very tiniest. Then one quarter of a rice grain.
Yeah, true. Our existence is very minuscule.
You're truly humble, David.
it will and
Yeah, so that's all I have to share. If you guys have any questions, I'd be happy to answer.
David, do you want to share like your experience, what all you have seen, and also how did you learn, and so?
So Google was the biggest source. Google had all the answers. Thank you, Google. Yeah, and also like few books, and also like I've been to one star party, and they like it was very helpful from them to learn basics about stargazing, and I've seen one or two other galaxies apart from Milky Way, and sadly I haven't seen Milky Way galaxy, uh, which I hope I will. Yeah, and it's really cool to know that I can spot planets effortlessly.
Yeah, and he will be sharing this I can see, that I can see, then we will be asking where. Yeah.
Well, learning astronomy is a very humbling experience.
Thank you, Davin. That was very informative, interesting.
You're welcome.
Share in the morning, 4 o'clock, he wakes up. Sometimes he keeps alarm for finding the planets or to see, and then he wakes up and he sees. Sometimes it will be cloudy, sometimes telescope is set. Everything is set, but we can't see them, and yeah, so many
he has
things
telescope.
at campus.
No, he has really.
No, I don't have a telescope.
Oh.
Even if we have in Bangalore, we can't see any
Yeah.
stars yet.
Doing naked
The
eye
weather,
astronomy
yeah.
at Bangalore itself is very difficult.
Yeah, the weather, yeah.
Weather is really bad.
Yeah.
Not only
What do you
weather,
mean?
it's more of light pollution.
Yeah, the thunder something come, you can't see anything. Yeah.
So it's really important when you're doing astronomy that your eyes aren't light doesn't interfere with your eyes. So the more used your eyes are to the dark, it's more nice to experience
Yeah,
stargazing.
when we were going to see that galaxy, we had to at least wait for half an hour because then only we could see all the stars.
Yeah.
How was
Some
your experience?
galaxies are in the
Anushka?
outside, yeah.
Sorry?
David?
How was your experience watching these stars in the desert?
It was really nice. Like, it was fun because we had to stay there till about 2 a.m. to actually see everything. So, yeah.
Yeah. So, what all you were able to trace or see?
Yeah, we saw the meteor shower, and we also saw like in the morning, like not morning, like about 3 a.m. or 2 a.m. we saw the Milky Way galaxy. We actually did not know it was gonna come, but then we saw it.
Milky Way came to 3 a.m.
Yeah, because you can't see them in like the sun in the daylight.
Oh. You didn't sleep that time.
No, we didn't.
Oh.
So
The whole night.
there are actually stars during the day, but we can't see them because the brightest star is, I mean, the star that's closest to us is blocking it, sunlight, the sun.
Yeah.
So because of the sun, we can't see the stars during the daytime all the time.
Thank you.
Welcome.
David, you can see the Brahma galaxy outside, yeah? Solar
What?
system, yeah? Amara galaxy is there, you know?
Andromeda galaxy.
Yeah.
Yeah, you can see it through telescope.
Oh, you can't come nearby. Yeah? It's not coming near. No.
Yeah. So in a few billion years, Andromeda is like slowly coming towards Milky Way. So Milky Way is here, and they're slowly coming together. But like we won't be alive to experience it.
Yeah, it'll
So
die.
eventually, it will collide and become one. It'll become Milktromeda.
Oh, milk, milk, something called, you know, milk, names will come, you know. Kaval, milk, some names are there, you know. Yeah?
Yeah, also we when we were seeing the Milky Way galaxy, we also happened to see the Andromeda galaxy, but like we couldn't see it fully because it was only like a dot because it was really far away.
Yeah. Seemed like a smudge.
Yeah, even smaller than a smudge.
Oh.
You can see Betelgeuse in very far away, yeah? Betelgeuse.
Betelgeuse.
It's very brightest, yeah? Brightest.
Yeah, you can see Betelgeuse in the constellation Orion.
Yeah, you can see one more UY, no?
UY Scooty.
So that is brightest. That is brightest. Yeah.
From here, I think the brightest star is Sirius. Sirius Beta.
No. Your city is brightest. In YouTube, I saw.
Yeah. Thank you, Zohar, for joining. Yeah. Zohar Shed. Thank you to Devin.
Welcome. Okay, so if you guys, oh yeah.
Yeah, so is there any website or anywhere where we can refer for information about the stars and stargazing, which you suggest?
You can actually just use the so yeah, that's actually an experience. Like you can go through
I
many
got you.
websites, but I don't actually go through a specific website. I just go to, like, I see a lot of websites, see different people, like what they have to share about it, and like it becomes one source, like it builds up and becomes one knowledge.
Okay.
Woman app also there. David, Woman app also there. Night Sky app, you know. Night Sky app.
Yeah, there's many apps and all, but like if you have a laptop, then I suggest you get Stellarium and get used to it, and it's really fun to use.
Yeah. Actually, it's also tried also.
Yeah, so if you guys don't have any further questions, anyway, it's just 2 minutes to 4. We can close it.
That was nice sharing about whatever you have been learning on astronomy and stargazing, sharing your experiences also, Devin. So you
Yeah,
have
it was
my
really
pleasure.
nice.
a lot
It
of
is nice.
information, yeah.
really happy to share it with you guys.
Yes.
You're so
Okay.
tired, huh?
Who, me?
Yeah.
I look tired. Oh.
Once I saw in the house somewhere. Smriti's
Hello
house.
there. Okay. Yes.
Okay.
Yeah,
Thanks
really.
for joining us,
Thank you
Devin
for
and
tagging along the
Spinnaker.
session. My pleasure sharing. Thank you.
Okay.
Bye.
Leela,
Yes.
Thanks,
again
Steven.
Monday is there, huh?
Sorry.
Bye,
Again
everyone.
Monday is there. Start
Mm,
gazing.
Monday, it is done, Hiren. It was a
Oh.
2-day workshop.
Oh. You can do 100 days. 100.
So you can connect with Devin now if you want to know more about stargazing.
Okay, okay.
On Discord, you can ask, and you can also call him.
Call him. I'm
Yeah,
trying
yeah.
to call him. He didn't pick up in Discord.
Okay, you can ask him, when can I call you? Can
He's
you
not
share?
there. Oh, he's not there.
He just left now.
Oh,
Ask
Oh.
him, ask his phone number if he can connect with you.
okay.
Okay. Yeah.
Okay.
He is open to share.
What are you doing? Huh?
Okay, chalo, let's go. Bye-bye.